Hello dear students, we are on chapter 6, heat and temperature, and the topic for today is anomalous expansion of water. So before we study about anomalous expansion of water, first we'll see what thermal expansion is. So the definition of thermal expansion is the expansion of a substance on heating is called thermal expansion of that substance. So it simply means that when you heat an object, the object expands. So that's thermal expansion. So when you are heating an object, you are supplying heat. So when you supply the heat, its size will be increased, or the substance will expand. So that's thermal expansion. Similarly, if you cool a substance, that means if you take the heat out from the body or substance, then it contracts. So the size decreases. That's called thermal contraction. Example: expansion of railway tracks during summer and contraction during winter. So during summer, because of heat, the gap which is present between the two rails in a railway track, it will be less, because the railway tracks will because the rails of the railway track, it will expand. And during winter, because of the cold, the gap increases, because the rails will contract during winter. So there are three types of thermal expansions. We'll see them one by one. Number one is linear expansion. Expansion in length of a substance is called linear expansion. Example: if we have a copper wire, if we have a thin copper wire, and if we heat that wire, then the wire will become longer. So there will be increase in its length. So this type of expansion is known as linear expansion. Number two, superficial expansion. Expansion in area of a substance. Example: a thin aluminium foil expands on heating. So if you take thin aluminium foil and if you heat it, then you will see that the area of this foil will increase. So there is an increase in the area of this substance. So this type of expansion is known as superficial expansion. Then number three, we have volume or cubical expansion. So this is expansion in volume of a substance. For example, if you take an iron ball and if you heat it, then after some time the size or the volume of the ball will increase. So this type of expansion is known as cubical or volume expansion. Now let's see anomalous expansion of water. The definition is the expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius is known as anomalous expansion of water. So usually when you take any substance other than water, for example iron, and when you heat it, then as the temperature increases, when you heat it, the temperature will increase, and as the temperature increases, the volume will increase, or the substance will expand. And similarly, if you cool it down, that is, if you decrease the temperature, then it will contract, or its volume decreases. So usually this happens with most of the substances. But in case of water, what will happen is, when you heat water from 0 degrees Celsius to 4 degrees Celsius, instead of expanding, it will contract. That means its volume will decrease, and its volume will become minimum at a temperature of 4 degrees Celsius. Now if you further heat water from 4 degrees Celsius and beyond, that is from 4 to 5, 5 to 6, 6 to 7, and so on, the volume of water again starts increasing, or the water will start to expand again. Similarly, if you cool the water from higher temperatures to the lower temperature, and as the water cools down, let's say from 6 degrees Celsius to 5 degrees Celsius, water will contract, or its volume will decrease. When it's cooled from 5 degree to 4 degree, again its volume decreases, or it will contract. Now if you cool water from 4 degrees Celsius till 0 degrees Celsius, now instead of contracting, now the water will expand. So this phenomenon or this unusual behavior of water is known as anomalous expansion of water. The expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius is called anomalous expansion of water. Now we know that the formula for density is equal to mass by volume. So volume and density, they are inversely proportional. That means if volume increases, density will decrease. If volume decreases, density will increase. So here at 4 degrees Celsius, the volume of water is minimum, and hence the density of water will be maximum at 4 degrees Celsius. So you have to keep this in mind. We will be applying this particular concept in our topics which will follow after this topic. Next we have is graphical representation of anomalous expansion of water. So whatever I just explained to you, same thing is represented in the form of graph. So there are two graphs. First one is volume temperature graph and the second one is density temperature graph. So here I'll explain the meaning of these two graphs. So first one is volume and temperature. So along y-axis we have volume and along x-axis we have temperature. Volume is in terms of centimeter cube and temperature is in terms of degree Celsius. So this is the variation of volume of 1 gram of water with increase in temperature. It means that we are taking 1 gram of water and we are heating this water. That means the temperature will increase. So with the increase in temperature, what will happen to its volume is what we are going to find it out here. So as you can see that when we are increasing the temperature, that means when we are heating water from 0 degrees Celsius to 4 degrees Celsius, water contracts. That means its volume decreases and it will reach its minimum value, or the volume will become minimum at 4 degrees Celsius. And if we further heat this water beyond 4 degrees Celsius, water will expand. That means the volume will increase. So this is how we represent this particular observation in the form of graph. Now let's see density temperature graph. So this is variation of density of water with increase in temperature. So we have density along y-axis and it's in terms of gram per cc, and we have temperature in degrees Celsius along x-axis. So when we heat this water from 0 degrees Celsius to 4 degrees Celsius, so when the temperature increases, what will happen to the volume? Volume will decrease and it will reach its minimum value at 4 degrees Celsius. So here, since density and volume, they are inversely proportional. So if volume decreases, density will increase. So density will increase with the increase in temperature and it will reach its maximum value at 4 degrees Celsius. At 4 degrees Celsius, volume is minimum, so density is maximum. And if we further heat this water beyond 4 degrees Celsius, the density will decrease because volume is increasing, and hence in this case the density is decreasing. So this is how we represent this observation with the help of this graph.